All right, so here's Thursday's lesson, 7.5, factoring polynomials by grouping. And for those of you that were in class on the early release day Friday, a lot of what we do today is going to be very familiar. So we are starting on page 20 in your packets. So factoring by grouping is kind of what it sounds like. We are going to group parts of our expression together. Before we do that, the first thing we always want to do, check for a greatest common factor. So I didn't put a spot in your notes as far as kind of the steps for the process. So I'm going to write them on the side here. And so we check all four terms. Is there a greatest common factor? The answer, no, not any, not just one. So we're good to go. Step 2, group two terms together. And most often, we'll group the first two and the last two. Then we're going to check for a greatest common factor. In each group. So in our first group, 5x to the 5th plus 20x to the 3rd, which I think I have a typo there. That should be x to the 4th. 5x to the 4th. They each have an x to the 3rd, and each number is divisible by 5. When we factor that out, we get x plus 4. 5 divided by 5 is 1. X to the 4th, we factored out x to the 3rd, leaves us x. 20 divided by 5 is 4. And we factored out the x cubed. Now look for a greatest common factor in our second set of terms. There will not be a variable in this one, but there is a number that evenly divides into both 6 and 24. And the largest number that divides into both is 6. 6x divided by 6 leaves us with x. 24 divided by 6 is 4. And you'll notice we have that x to the 4th in both terms there. So the next step, factor out a common term. So we're going to take out the x to the 4th. I'm sorry, the x plus 4. And what we have left when we remove the x to the 4th, we have 5x to the 3rd plus 6. And the last step, can either term be factored? The x plus 4 can't be factored, it's linear. The 5x cubed plus 6 also we cannot factor with any way that we know at this point. So that's our final answer. Example B. Group the first, first check to see if there's a greatest common factor with all four terms. In this case, there is not. Group terms into terms and factor out from each term a greatest common factor. The 6x cubed minus 16x squared has a greatest common factor. Both terms have an x squared. And the 6x and the 16 are both divisible by 2. 6 divided by 2 is 3. X cubed, when we factor out an x squared, it leaves us with an x. Minus 16 divided by 2 is 8. And we factored out the x squared, so that doesn't have a variable. 3x plus 8, the greatest common factor there is 1. And in this case, I am going to write the 1 as the greatest common factor. It makes the last step a little bit easier. So I have, again, that common term, 3x minus 8. I'm going to take that out. And when I take that out, I have 2x squared plus 1. Can I factor 3x minus 8? Well, it's a linear factor, so no. Can I factor 2x squared plus 1? And the answer is no. Now, if that were two terms with subtraction, there's a possibility I could have a difference of 2 squares. But in this case, it's addition, so we cannot factor it. All right, so here's your first try now. Go ahead and pause the video, try to find the solution, and then once you think you've got it factored, go ahead and restart the video and see if you're right. In this case, there is not a greatest common factor for all four terms. So we can group, and I always group the first two and the last two, just a personal preference. That way I don't have to rewrite anything. My first group has a greatest common factor. It has an x squared. Also, 10 and 25 are both evenly divisible by 5. Now, what I have left, 10 divided by 5 is 2. I had x cubed. I factored out an x squared. That leaves me with an x. 25 divided by 5 is 5. I had an x squared, but I factored it out. So there's my first term with my greatest common factor removed. Plus 4x minus 10 has a greatest common factor of 2. 4x divided by 2 is 2x. Minus 10 divided by 2 is 5. And now we can see we've got that 2x minus 5. I factor that out. And when I factor that out, what I have left, 5x squared plus 2. And then I check, can I factor that any further? The 2x minus 5 cannot be factored because it's a linear term. 5x squared plus 2 cannot be factored because it's only two terms and it is not a difference of 2 squares. Moving on. So the other thing that could happen is we could have subtraction on that third term, and that's very important to recognize because it does change the way we group things. first of all, I check again, is there a greatest common factor between all 4 terms? And in this case, there is not. But when I group, that subtraction symbol goes in my second group. And now I look for my greatest common factor in each group. 4x cubed plus 8x squared. Well, they both have a 4 that divides evenly, and they both have an x squared. My first term, 4 divided by 4 is 1. X cubed, I factored out x squared, leaves me with x. 8 divided by 4 should be just x, not x squared. Sorry about that. 8 divided by 4 is 2. I had an x squared, but I factored it out. In my second group, I have minus 5x minus 10. Whenever we have that negative in front, that's part of our greatest common factor. We're going to factor out a negative. In this case, the 5x and the 10 are both evenly divisible by 5. So I have negative 5x divided by negative 5, leaves me with just 1x. Negative 10 divided by negative 5 is 2. The x plus 2 is my common factor that can come out. When I factor that out, I'm left with 4x squared minus 5. The x plus 2 cannot be factored any further. 4x squared minus 5. Well, now here we have a difference of 2 values, and one of them is 4x squared. That is a perfect square. However, 5 is not. So we're not going to factor that any further. That's how we're going to leave it. Take a look at the next example. (27) x to the third plus 45x squared minus 3x minus 5. In this case, there is not a greatest common factor other than 1 for all 4 terms. So now I factor by grouping. In my first group of 2 terms, both numbers are evenly divisible by 9. And they both have at least an x squared. 27 divided by 9 is 3. I had x cubed. I factored out x squared, so that leaves me with an x. Plus 45 divided by 9 is 5. I had an x squared, but I factored it out. In my second group, it looks like the only common factor there is 1, but again, we have that negative. So we're going to factor out a negative 1. And then we have 3x plus 5. We have that 3x plus 5 in both cases. And when we factor that out, we have 9x squared minus 1. So again, check this second factor, the second term there. Can we factor it? And 9 is a perfect square, 1 is a perfect square. This one can be factored. So we do need to take one more step. And if you remember that difference of squares, we take the square root of the first term, 3x, plus the square root of the second, and 3x minus the square root of the second. So this is our final answer. A little bit more involved process when the result is a perfect square in our first factoring step. All right, so here's one for you to try on your own. Again, stop the video, give it a shot, see what you get, and then go ahead and restart the video and check your answer. In this case, there is no greatest common factor for all four terms other than 1. So we'll group our first set of terms. Do not have a number for greatest common factor, but they both have an x squared. So we have 2. Had x cubed factored on x squared, so we're left with x plus 1. X squared divided by x squared is 1. Very important that we include that 1 in our factoring. Our second group, both are divisible by 7, and there's a negative there, so I'm going to factor out a minus 7. Negative 14 divided by negative 7 is 2. We have that x. Negative 7 divided by negative 7 is positive 1. We have our common term that I can factor out, 2x plus 1. Leaves us with x squared minus 7. X squared is a perfect square. 7 is not. So I do not need to factor it any further. And that is my final answer. We'll do some more work with these on Friday. So if you have questions, feel free to ask on Friday. And then, like I said, we'll do some more examples, hopefully clear up any questions that you have. I hope you're enjoying your snow day, and I look forward to seeing you on Friday.